So today's video, we're going to take a look at the process of installing Debian into our VirtualBox environment. Now, as you can see, I use VirtualBox for virtual machines quite a bit. What we have with this environment is the ability to take software and emulate physical PC hardware. What we're going to do is we're going to create a configuration that says, when I start up this virtual machine, I'm going to run Debian inside of this environment, and VirtualBox, you are going to emulate a PC for me so I can run my Debian. So for us to do this, we have to configure a virtual machine to run our Debian operating system, which we are going to use in our InfoSec Linux and InfoSec Python classes. So for this to work, you have to download and install VirtualBox Manager. Now the process, the links to download are in Learn. The process to install VirtualBox are in the handout. I'm not going to cover this now because clearly I already have VirtualBox installed and running. But I am going to go through the process of creating a virtual machine and installing Debian on that virtual machine to the specifications that we use in this class. Let's begin. First things first, these are called groups. You don't have to have groups in VirtualBox. Because I use VirtualBox so much in so many different classes, I create groups for my virtual machines. You don't need to worry about that. You really don't. It's out of scope. But if you really want to, you can select a virtual machine and you can start assigning groups to them. It's under machine group. You can start creating groups of virtual machines. It's out of scope, but if you want, you can, of course, play with it. What I am going to do is I'm going to create a new virtual machine. I'm going to go I'm going to go Machine, New. I can also hit Control-N. I can also click on the new icon right here. VirtualBox often lets you do the same thing a number of different ways. So that's what I'm going to do. Click on New. Now I could go in here and say the type is Linux. I could scroll through and try and find Debian 64-bit Linux, but I'm just going to show you something. If I have Windows and it says Windows 7, Windows 10, Windows whatever, if I start typing in Debian as the name, as soon as I get to the B in Debian, the wizard that VirtualBox uses for creating a virtual machine is aware enough to assume that you probably want to create Debian, and it's probably going to be a 64-bit version of Debian, which of course is a type of Linux. So just by typing in Debian, it recognizes that I probably want to set up a 64-bit version of Linux Debian, which is what I want. So you can type in a name. I recommend Debian. You should ensure the type is Linux and specifically 64-bit Linux, because that's what we downloaded. That's the link that you had in Learn. You can then click on Next. You need to give yourself some memory. 1 gig is enough. If you want, you can give yourself 2 gig of memory, 2048. For what we're doing in this class, 1 or 2 gig is enough. You can click on Next. The next thing is creating a virtual disk for our virtual machine. Now at this point, the defaults are typically fine. It's going to recommend an 8 gig hard drive. If you are messing around with Ubuntu, Kubuntu, or Xubuntu, if you're playing with the graphical environments, you're going to want 20 gig. But if you're following the lecture notes and only installing what I'm asking you to install, or if you're downloading Debian and you're not downloading Ubuntu, then 8 gig is enough. If you run out of space, you need to give yourself a bigger hard drive and try again. Alright? You want to create a virtual disk now. There are times when you create a virtual machine and you add a disk to it. There are times when you run a virtual machine without a hard drive. You just run it off of an optical media. But for what we're doing now, you want to create the virtual disk now. So you click on the default Create. And then this will bring up another wizard, and this will walk you through the process of creating the hard drive. The defaults are fine. VDI, that's just the type of virtual disk we're creating, default, fine. Dynamically allocated, the difference here is that rather than creating a huge 8 gig file, it'll create a small file and grow it as necessary. It'll grow it up to about 1.5 to 2 gig in size. It will never claim the full 8 gigabytes in size. So dynamically allocated again is fine. Default is fine. Click on next. And then the size. As I said, 8 gig should be lots for most of us. You can then click on create. And that's it. You've created a virtual machine. You haven't installed the operating system yet, but you have created the virtual machine. At this point, we could fire it up, but we have a couple of more steps we want to make before we click on start. We want to go through and tweak some of these settings. You can, when the machine is selected, you can click on settings. When the machine is selected, you can go machine settings. You can right click and select settings, or you can actually click on the word for the different category of settings. For example, I can right click, select settings, and it'll take me to the general tab. But if I know I want to take a look at the system settings, I can actually click on the word system, and it'll open up the settings dialog box on the system tab. On this, 2 gig is fine. The processor, 1 core is fine. You can give yourself a second core if you really want. There's no value. Again, what we're doing is pretty lightweight for Debian. So 1 or 2 core, it's up to you. For the display settings, we don't need to make any changes here. When we set up, in future classes, when we set up Kali Linux and we set up Remnux, both of which are Ubuntu or Xubuntu based, Ubuntu with the XFCE interface, we may want to mess around with our graphical settings then. But for now, this is fine. Storage, we do need to make a change. We have our hard drive right here. It's 8 gig in size, but really it's only using 2 meg now. The smallest amount of space it can take is 2 meg, and that's what it's taken right now. We also have our optical drive here. It shows it as empty. What we need to do is we need to say, hey, I want you to use that ISO file that I downloaded. So you can go to your downloads and you can select the ISO file that you downloaded. Okay? And then that's fine. So, nothing on general. If you want, you can give yourself more memory. You can give yourself a second core, but nothing really needs to happen on system. Certainly nothing on display for our video display. But with storage, we want to add our optical media. And for audio, we don't need to worry about it. For network, we want to add a second network adapter. We will be using 2 network adapters, not really relevant for Debian or for Python in this class. But when we get into Kali Linux and when we get into Remnux, when we get into hacking websites and creating malware in semesters 2 and 3 respectively, I should say, we are going to want to have a separate network for those kinds of activities. To that end, we're going to have 2 network adapters on our machines by and large. We have 1 adapter running on NAT, as we see right here. We're going to go to our second adapter. Nothing's working because it's not enabled. It's all grayed out. When we enable it, then we can say, hey, you know what? Use the host-only adapter. You should only have 1, and you want to change promiscuous mode to allow all. So for network, adapter 1 is fine, don't change it. Adapter 2, we enable, make it a host-only adapter. It should default to the VirtualBox host-only Ethernet adapter. And we need to go to advanced and set promiscuous mode to allow all. And that allows our host operating machine to talk to the virtual machine and the virtual machine to talk to the host. Nothing else should need changing. Interfaces, USB, serial ports, nothing needs changing. Really, to get this machine ready to install Debian, 2 changes need to be made. We need to add the install media that we downloaded, and we need to enable a second network adapter so that we can talk on the host-only network. Otherwise, everything else can and should be fine. You can click on OK, and now you can start up your VM. But a sanity check. We can see for the optical drive under storage, we can see that our Debian install CD has been selected. We can also see that we have two network adapters, one on NAT, one on the host-only network. We should be good. We can now click Start. Now when we start our Debian virtual machine, it'll bring up this. Now it says graphical install, but we really don't have a mouse in there. We have to use the cursor keys on our keyboard. But fortunately, it's already got the correct thing highlighted. So all we need to do when it says graphical install, when this pops up, we just need to hit enter. And it will launch the graphic installer of Debian. Okay? Just going to adjust it here so it's a little bit more visible. But that's what this is. This allows us to install Debian using our mouse. We can click now on different things. And basically what it's doing is it's running a graphical version of Linux right now. It's running an installer version of, I believe it's Debian, in a graphical environment to allow us to now install Debian. Okay? It's kind of a nice feature. Alright, so let's go through the installation process. Now, you may be inclined, if your native language is not English, you may be inclined to use another native language. And of course, there's nothing wrong with that, but I'll ask you to remember that sometimes software written for these environments don't always follow the language packs properly. What does that mean? It means that if you choose another language to run your Debian in, and then we install software and it doesn't do the language packs properly, it may not run in Debian. And this is the same thing for Windows and other environments as well. By and large, I encourage people to use one language, English. Not because it's better, nothing like that. It is because sometimes developers don't do language packs properly, and if you have another language other than English, or other than the language that the developer expects you to use, it might not work. If you're running software from China that is written in Chinese, then of course you may want to consider setting up your operating system in Chinese, because you can assume that the language packs are going to be compatible. But in this class we use mostly English software, so you probably want to set your operating systems to be in English. So we're going to select that and either click on continue, or you can just hit enter. Now you should specify the country properly. I'm going to hit C for Canada. It finds Canada, and now I can hit enter or click on continue. The keyboard, I find most of us are fine if we use American English. There's an abstraction between our real keyboard and the keyboard that is used inside the virtual machine. Sometimes there's some issues, but I haven't seen an issue with this in a very long time. We're going to use American English. The first thing it's going to do is it's going to start grabbing a basic operating system. It's going to extend the operating system running in memory right now. There's a segment of the memory that's acting as a hard drive, and it's just adding stuff to that temporary hard drive that's running in RAM. Now, because we set up two adapters when we configured the hardware, it's now saying, hey, I found two adapters, which of course we expected. Which one do you want me to use? What it's asking us here is which one is connected to the internet. Which one of these adapters can I use to update and download software when I'm installing this? The first adapter was configured to NAT, which stands for Network Address Translation. That's the adapter that can talk through your host operating system, Windows, or for some of you, the Mac OS. That's the one that can go out, talk on the internet, and download the necessary software. That's the one that's configured as NAT. That was our first adapter, ENP0S3, so we should be fine with that. Click on Continue. It'll take a few seconds to configure the network settings, and then it'll move on to starting naming devices. Now, defaults are fine here. We don't actually use machine and domain naming in our classes. We do everything with IP addresses, because that's what pen testers use when they're attacking resources on the network. There are scenarios when you want to use machine identities, machine names, but by and large we usually do stuff via IP addressing, so machine names aren't relevant. But I like to give my machine a very short name, such as Deb. When it comes to the domain name, traditionally I use the following domain, opsys.bit, It just pays homage to an instructor we had here at the college a while ago. So, but both of those are optional. You can call your machine, your host name, and your domain name anything you want. We're going to set up a root password, and then we're going to create a regular user. I am going to set up very bad passwords. Even though I'm going to post this to YouTube, and in theory, the world can see my passwords, I want you to keep something in mind. I would never do this in the real world. And when we talk about security at Red River, we always insist that you use proper password disciplines. However, this is an academic exercise running inside of a closed architecture inside of your instance of Windows. If people are actually getting into your Debian virtual machine and logging in as root, you have much bigger problems than the password that you're using. As a general rule, in these classes, I recommend my students pick one password and stick with it. Don't try and change passwords, having different passwords for everything, because you're just adding a degree of complexity to your lessons. I agree, it does set a dangerous precedent. I agree, it does, build up bad habits. But I believe the academic benefits outweigh those risks. So I always use very simple passwords. I tend to use the same passwords over and over again, so I don't have a lot to remember for these classes. So this is for the root account. That's kind of the administrator account, what we call the hand of God access to the system. Next thing it says, give me a full user. I never give a full user. I just give the user ID I want to use, because that's what it's going to recommend next. Again, I use a short user ID. Just like I used a short host name, DEB for the host name, SJAY for the username. And again, I'm going to use very similar, simple passwords for my username password. It'll go through and do some basic settings, and if it ever looks like things are hung up, you can always check down here in the status bar, and it'll tell you any activity that is happening. Now in Winnipeg, we are in Central Time, and you can see it's reading from the CD, it's reading from the hard drive. It may even start talking to the network occasionally. That's what you want to see. So if you're ever curious, just take a look at your status bar and make sure that stuff is happening. Now, we set up our hard drive when we were configuring our virtual machine. Now we need to set up space on that hard drive to install our operating system. We will expand this in greater detail when we talk about partitions and adding partitions to our Linux in a future lecture. But for right now, what we need to do is we need to create a basic system. And the defaults for this process are going to be adequate. Guided, use the entire disk. Default, continue. It's going to recommend a device. Default, continue. It's going to make a recommendation that everything is in one partition. We're going to modify this in a future class, but for now, everything in one partition is fine. Continue. All right. It's going to say, I suggest we set up your hard drive like this. Is that agreeable? Default is fine. Continue. It's on this screen where it says yes, no. It's saying, listen, I'm about to change your hard drive. Are you sure? Okay. Now, it's not changing the hard drive. It's changing a single file on the Windows file system that represents the hard drive that Debian is going to use. The hard drive is represented in a single file, and it's saying, hey, are you sure you want me to make this change? You have to click yes, and you have to click continue. It will partition the hard drive, it will format the partitions that it creates, and then it'll install the basic system. And now you can see your task, your system tray down here is showing red for the hard drive. It's writing to the hard drive. So again, if things ever look paused, we can check down here on the status bar and verify that things are progressing properly. If need be, you can pause this video and allow your installation to get caught up. Once it's installed everything that it had on that CD-ROM image we downloaded, it's now going to say, hey, do you have any other CD-ROMs you want me to use? We're going to say no and click on continue, because we're going to say do everything from this point onward from an online repositories. Again, because we said we're installing from Canada, it's going to say, hey, can I find an archive or repository? Where do I look? Look in Canada. Continue. It's going to make a recommendation. Please ensure that you use either deb.debian.org or ftp.ca.debian.org. I want you to ensure that you use one of those two. Don't use some of the school ones. We've used some of these school servers, and I don't know if it was our classes, but we would use them and then they would just go offline. I don't know if it was too much traffic. So I no longer recommend using anything other than one of the Debian repositories. Please. Okay? Now, if you're installing from home, you might need to change this, but we rarely need to make any changes to this. So you shouldn't have to change anything there. You should be able to just click on continue. And if it starts retrieving files, or more importantly, you see green reads happening on the network. It's pulling stuff from the network and it's writing it to the hard drive. Our network's configured properly. It's found the online repository. We're actually installing stuff from the internet onto our virtual hard drive. Perfect. This is taking an embarrassing long amount of time, but we have to let it run its process. If it's taking me this long from my home network, it's probably taking you this long from your network as well, so we'll just let it run. Or I'll just get bored and cut out large chunks in the video and you'll pause the video while playing it back. Perfect. Now the first thing it confirms, it says, hey, do you want to install this package called Popularity Contest? Generally, I say no to this, not because I don't want to share information with Debian. I think that's actually a good thing. You know, they should see what people are doing with their software and adjust the core components accordingly. But what we do in InfoSec, what we do at Red River, I don't think we should be impacting as much as we might. I don't think we should be impacting what they do based on the activities we do inside Red River. So by and large, I say no to that and then continue. And then it'll ask me, well, what software do you want to install? And this is where things get critical. I want you to clear everything. All the checkboxes need to be clear. Everything is clear except for the last two. The only things you should be installing are SSH server and standard system utilities. Everything else should be cleared. It's a habit I want you to get into when you're setting up software and systems in information security. Don't install things that are not necessary. We'll see this next semester when we do pen testing. Often what we end up exploiting is software that is running on systems that shouldn't be running on systems in the first place. So by and large, don't install anything unnecessary. After it is downloaded and installed all the software, which can happen fairly quickly as you just saw, the last thing it wants to do is to install a bootloader. Now, as we discussed in class, there are 3 components to getting a system booting in the PC world. And inside of VirtualBox, we are emulating that PC world. You need a BIOS, you need the operating system that you're going to run, which in this case is Debian Linux, but you need something called the bootloader. The BIOS will call the bootloader. The bootloader will then try and load the operating system. That's what we're doing now. We are installing a bootloader so that the virtual BIOS and VirtualBox can actually call and run Debian. So, do you want to install a bootloader? Yes, we want to install a bootloader because it is required. Even Windows uses a bootloader. It doesn't ask you to install one, it installs it automatically. It installs, I think it's still called WinBoot, but it could have changed. Like we did when we were actually saving our changes to the partitions to the hard drive, and we had to say, yes, save our changes. Because this will change the bootloader that your hard drive uses, it's saying, okay, you tell me where you want to install this bootloader, because I'm not making any guesses. So you have to tell it to install it to something called /dev/SDA. Because it will overwrite the boot sector or the boot partition of the hard drive. It's not doing it because it's a file on Windows partition. It's not doing anything to the hard drive. But the installer doesn't really know that yet. So we have to tell it, no, install it right there, and then continue. It will then install grub, and then it'll say, hey, I'm going to clean up some files, eject the CD, but VirtualBox will do that for us, and then we are good to go. And it'll reboot the system for us, and our installation will be complete. Again, if things look like they might be stalled, you can always check the status bar. You can see little activity icons, especially the V and what looks like a chip. That's how active the processor is. All of these things will tell you if your system is actually working. And there we go. Everything's good. As we click on continue, it will then reboot our newly minted instance of Debian. When it comes up, this is the grub that we installed at the end, but after a couple of seconds, it will boot into Debian for us, and we get to log in. Now, if you recall, I created an account for a user called SJ, and then I'm going to type in the password. It doesn't display anything back when I'm typing the password. If you get it wrong, you get something like this. So you have to try again with the username again. It's not saying, hey, try your password again. It's saying, try logging in again. So again, you have to give the correct username and the correct password, and then you're logged in. If you're following this lecture, we did not create a graphical environment. We only created a command line environment. I strongly encourage you to do that because pen testers and security people, by and large, do everything through the terminal. So setting up a graphical environment has very little value at this point. We will be using, as I said earlier, we will be using a couple of instances of Ubuntu, which is a graphical version, very, very, very similar to Debian, very strongly based on Debian, although it is getting more diverged from the core Debian sets of code. It is very Debian-like, this Ubuntu that we are going to be using in the future. But for our purposes right now, this is all we need. Once you have everything done, what I want you to do is machine ACPI shutdown. That's how I want you. I don't want you going, hey, I'm just going to shut this down and power off my machine. Don't do that. You can put it to sleep, all right? You can right-click and pause it. But what I want you to do is the machine ACPI shutdown. And what this does, this is basically a trick that we use that battery backup systems would send a signal to machines that, hey, I'm about to shut down. If you want to save your files, elegantly shut down now. And that's what we use to power down our instance of Debian. That's it. If you have any questions, let your instructor know. I'll talk to you later. Bye-bye.